Hello, this is Bradley Thayer, coming to you on behalf of the PHP and MySQL course at South Mountain. This week, week 16, we are looking at a concept called a graph database. First 14 weeks, we looked at relational database and we used MySQL. In the 15th week, we did a very brief overview of a NoSQL database, the concept of a document database, and the one we used, for example, was MongoDB. This week, just a very light approach, very 40,000 foot approach here, just to show you kind of high level what a document database looks like. And we're going to use the one called Neo4j. Like MongoDB, Neo4j can be downloaded with a community license, so you're free to go to their website, and with a community license you can do a lot of stuff. But one of the things you can do for certain is try some sandbox activities, after the course is over, and you can try it out, play around with it, try some new things, and hopefully, fall in love with other ways to store data and do some personal investigation. I hope that's what you end up doing. It's how I learned Neo4j, so best of luck to you there. But for our course in week 16, we just want to do a brief introduction to show you other ways that we store data. A graph database stores data in the concept of an entity and a relationship. Now, an entity would be any of a number of common things that can be lumped together with common attributes, common likenesses, and whatnot. So in the case of our work we've done this semester, a dog, like your pet dog, would be a concept of an entity. Fido, Spot, Snoopy, Scooby, Rin Tin Tin, any number of dogs. They're different dogs, but they all share a common attribute of being a dog. And that's why we can lump them into an entity. Some of the more common cats out there, Garfield, whatnot, there'd be a cat entity. If you have a pet snake, you have a snake entity. You have a giraffe entity. All these animals have their own entities. Okay, people can be an entity. A teacher, a student can be an entity. Something that you can encapsulate into something that has common attributes that you can put into a category. That would be an entity. The relationship is how they relate to each other. So let's start off with a dog real quick. So I'm going to create a dog node. Give the dog a name. In this case, we'll just do Snoopy. Okay. So if I click right here, I should see a Snoopy node. So there's the node Snoopy. So another dog, I guess I could use Rin Tin Tin, or let's keep it with, how about Scooby Doo? That'll work. I like Scooby Doo better because I know Scooby Doo's owner is Shaggy. Okay, so I have two dog nodes here. And let's say I want to create owner nodes. Okay, so I'm going to create owner, and I'll give the owner a name. In this case, it'll be Charlie Brown. And you can give a node more than one attribute. I've given the dogs just names, but I can give, let's say, a birth date. I could give this as a string or as a number. Neo4j holds numbers, holds dates. It's either strings or numbers. Okay, so not a true date object like we could have in a column in MySQL. So I've had here what's called an epoch converter, which translates times from 1970, January 1st, 1970 to the current time. So let's just say, for sake of argument, that Charlie Brown was born in 1990 on October 1st. We'll just say he was born right at midnight. Okay, so the time in milliseconds is right there. So that's the number of milliseconds that it took from 1970, January 1st, 1970, all the way up till this date I've put in here. So I could give Charlie Brown that birth date. I create Charlie Brown, and wouldn't you know, he's right here. When I hover over Charlie Brown, you see the birth date there and the name. Now, whatever application is calling this, is querying this database, would be responsible for converting that number into a meaningful date format. I could use a string date, but the same way with MySQL, I lose the ability to sort that very well. Okay, so the birth date as a number, like it is right here, is more sortable. To get, if I have 15 owner nodes, I can sort them by birth date. The number is a better approach. Okay, so I said a relationship. I have entities here, now a relationship. So I can say that the owner and the dog. So I'm matching the owner of dog where o.name equals Charlie Brown and d.name equals Snoopy. And I want to create a relationship here, and I want to say owner. The owner owns the dog. That created one relationship for us. I click on Charlie Brown, and now you see what it says. Snoopy owns Charlie Brown. That's not right. We don't want that. So I'm going to delete that, and I'll show you what I did and why that's incorrect. So I'm going to say match owner relationship dog, delete R. Done. I refresh that. Charlie Brown doesn't have a dog now. And if I don't specify the direction, it might make up one for me. So I'm going to put a arrow there. Now I'll hit enter. I've created the relationship again, and now it should be right. Indeed, Charlie Brown owns Snoopy. Okay. I need another owner for Shaggy. I think Shaggy has a last name. I don't immediately know it. So I'm just going to give him one name. I'll give him the same birth date, although Scooby-Doo cartoon goes way back in time, much beyond 1990. Of course, Peanuts does too. It's just for the sake of this example. So we have Shaggy, right? And I need to make a relationship between Shaggy and Scooby-Doo. One relationship created. Now if I say dog, Snoopy, and I have Shaggy. Okay. So what might be some things we might do this. So if you port this over to our example we did with owner, dog, and let's say a rabies vaccine, right? So we talked about a um, concept of having a vaccine. There's probably scores a way to do this, and it would all depend on how your organization sets up their data. But just again, a rough example here. Let's say I create a vaccine, and I'm going to say the type is rabies, and I'm going to say the brand is Acme. So this is a little Wile E. Coyote here now. I'm mixing all the cartoons up. Okay. So what I could do here, again, this is just thinking off the top of my head right here, because I'm just trying to make an example for you. I have this vaccine here, and I have a brand name. I could have put a lot number or a expiration date, things of that nature, right? But again, I just want to say that I'm going to match Snoopy, so D dog, and V vaccine, where D dot name equals Snoopy. Charlie Brown would likely vaccinate Snoopy, I think. So I have Snoopy and V dot type equals rabies. I would create a unique relationship where I have my dog, a relationship here, vaccinated, with the vaccine. Okay. I could make sure I get the syntax right here. I could say vaccinated date. I can give a property or an attribute on the relationship as well. Okay. So I won't do that right here. I don't want to overburden you here with too much example here, but I'm going to create, if I create this right here, all of a sudden you see Snoopy is vaccinated with this Acme brand rabies vaccine. Now it says Acme here. What if I want to see the type? Well, that's the beauty of the graph database. All I have to do is that, and voila, I can see any property of that node displayed on the screen right here. I can write queries. Like I mentioned, I can do date queries. I can say, show me all the owners that are greater than a certain birth date. So we did discounts for senior citizens. We could put a attribute on there on the node for a military status, a veteran status, to say we want to give a discount for being a veteran, any of a number of things like that as well. So we could have done our whole example here with a graph database, and it would have had its pros and cons. Remember last week I mentioned, don't consider a NoSQL database to be a replacement of a relational database. Consider it to be a complement, where there may be cases where one outshines the other, but they never replace each other, right? You always want them to coexist so that they can be used when they are most strong, and you're not trying to shoehorn a certain database type into a situation where it probably is best left for the other one. Okay, and you learn those cases, as you get experience and whatnot. Don't worry about that part. Just understand that they kind of can coexist. So really quick, I want to do another quick example. So Neo4j comes with their own example here, and I'll find it here. They have an example graph, the movie graph. I kind of like this one. So they give you this to run. Okay, so I'm going to run this right here. It imports a bunch of entities, relationships for a bunch of movies, actors, directors, and things of that nature. So as soon as it loads, it may take it just a second. And there we have it. Okay, so you can kind of see what's going on here. Tom Hanks acted in The Green Mile, and Penny Marshall directed A League of Their Own. You kind of see how this all these all relate. Okay, I can do this, and you can expand. I can zoom out a bit, and you can kind of see how big this graph is. It would keep going. I think I've only zoomed in on a couple of pieces, but I could keep expanding this out to other parts. Okay, so I have a bunch of actors in here, a bunch of directors, a bunch of movies. So you see how the directors and the actors are all part of a person node. Okay, they're all people. They just happen to have a different job in the movie making business. All right, so they have a different role. So you see how that role is defined in the relationship. Penny Marshall directed, while Ron Howard directed, while Tom Hanks acted. Okay, but these are all people nodes. Okay. So they give us a couple of more things we can look up that are kind of interesting, I think. Okay, I can say, what's a good example? Let's see. Well, this is very simple here. Who directed Cloud Atlas? Okay, so the movie Cloud Atlas. I want a. It looks like it had 3 directors. Okay, it's an interesting example. Who are Tom Hanks's co-actors? That would be an interesting example. So these people have all acted with Tom Hanks. Maybe you can just look at these and think of a few movies where these people have been co-actors. I'm trying to think of when Madonna and Tom Hanks were in a movie, but according to our data here, they were. Okay. We can say, list all Tom Hanks movies. Lots of examples. It gets more interesting as a graph, though, when you start looking at this. Movies and actors up to 4 hops away from Kevin Bacon. Now, if you follow any pop culture, you know Kevin Bacon has this special mysticism in the data world, or people. No matter who you are on Earth, you're only 7 hops away from Kevin Bacon. You know somebody who knows somebody. You do that 7 times. Kevin Bacon, eventually you arrive there. Okay. So this graph here, this subgraph that we have here, starts with Kevin Bacon, wherever he is on this, and it says, give me everything that's 4 hops away. So there he is right there. So this only has a single hop, or that is a single hop. So 1 hop, 2 hops, 3 hops, 4 hops right here to Chris Columbus, the director. Okay. So that's the idea there. So you can kind of see you get this neighbor type relationship that may or may not be interesting in a a movie graph, but you can kind of start to see that if you're some sort of data forensics person and you're trying to see, okay, who are all these people making these bank transactions? Well, you can kind of see now finding these neighbor nodes may have some interest to you. Okay. Another kind of one I find interesting is who can introduce Tom Hanks and Tom Cruise. Okay. So Tom Hanks and Tom Cruise, they didn't act in a movie together, but they're both big name actors. Certainly there's somebody out there who's acted with one of them and that can say, hey Tom, I know both of you. Here, I want to introduce you. Who is that? I can't think of it, but so this movie graph here will tell me. Who do you think it is? Well, there it is. It's actually 3 people. Tom Cruise acted in Top Gun with Meg Ryan, and Tom Hanks acted in You've Got Mail, Sleepless in Seattle, and Joe versus the Volcano with Meg Ryan. Tom Hanks acted with Kevin Bacon in Apollo 13, and A Few Good Men, Kevin Bacon with Tom Cruise. And Bonnie Hunt was in Jerry Maguire and The Green Mile. Tom Hanks and Tom Cruise are linked in that direction. Okay. That seems interesting to me. So you can kind of think of a Facebook or a LinkedIn type thing, a social media where you're trying to see who knows who can introduce. So you notice you get these kind of recommendations when you go to certain social media platforms. Hey, do you know this person? Things of that nature. If you go to LinkedIn, sometimes you'll see a 2 or a 3. It's kind of telling you how many nodes away you are from that person. Okay, if you're a 2, that means you're kind of like this Tom Cruise, Tom Hanks type relationship. Okay. One last example here. Let's do this co-actors. Extend Tom Hanks co-actors to find co-actors who haven't worked with Tom Hanks. So these are all the people that have worked with the people Tom Hanks have worked with. Okay, so that makes sense. Tom Hanks has worked with a person. That person has worked with a person. Who are they? And you see this kind of strength factor applied. Okay. And that's the number. You see that. Remember we did the count query in our MySQL course. That's kind of the same concept here. Okay. So you can see we have ordered by here like we did with MySQL. There's a lot of overlap. Okay. So the strongest co-actor with Tom Cruise is Zach Greener. The weakest, there's a lot of them here: Robin Williams, Renee Zellweger, whatnot. Okay. I think I even saw Carrie Fisher in here. Yeah. So Star Wars is coming out soon. Of course, she passed away a few years ago, but her character still plays on in Princess Leia in Star Wars. Alrighty. So hopefully that's been a good warm-up kind of exercise for you. You can go to neo4j.com. You can look all about the graph database here, how it might pertain to you. I like looking at some of the solutions: artificial intelligence, fraud detection, network IT operations, social networking. We kind of talked about that briefly. Risk and compliance, knowledge graphs. I like the fraud detection, combat fraud, money laundering real time. So again, that's kind of like that. Okay, I can see some activity on this bank account, or I can see some activity with this shady organization, etc. Who is, where's the money being? So you can kind of trace the money and find out who's laundering money. You can figure out who's hitting bank accounts, who is sharing illicit, stolen personal data, a lot of things like that. The graph can help you with. I encourage you to click on all these links, read about it at your convenience. After you've done watching this video, there is a short quiz on Canvas. I encourage you to go and take it as soon as you can, and you'll be done with week 16. Week 16 was just this brief introduction to the graph database. I really love the graph database. It's actually my favorite of the NoSQL. Close second is the document and NoSQL, so I enjoy them both. But again, I use relational as well on a daily basis. So I use all three of them. I find all three of them have their place in business. And I encourage you, as you try to build your resume, to at least explore these alternatives so you can say that you have a little bit of experience. It can only help you to add more types of databases to your resume. And I encourage you to try to do that as you can, as time allows you. Thank you again for watching. Please take the quiz as soon as you can. If you have any questions, feel free to contact me. Thank you.